Hello viewers, in today's class we are going to discuss an important problem from relations and functions related to the concept of equivalence relation, right? So here we have this problem in which we are given a relation R which is defined on the set of rational numbers. So here the capital Q denotes the set of rational numbers, and if two elements A and B belongs to the set of rational numbers, then A and B are related if and only if this relation holds. That is, a mod of A minus B is less than or equal to 1, right? And here we have to show that this relation R is not an equivalence relation, right? So what we will do before proceeding further, let us quickly revisit the definition of equivalence relation. Namely, here we'll see the definition of reflexive relation, then symmetric relation, and then transitive relation, right? So let us consider a set A, and let us consider the elements A, B, and C belonging to this set A, right? And if we define a relation, say R, on this set A, then this set A has the relation that is reflexive relation if each element of this set A is related to itself, right? So the relation R, which is defined on this set A, is said to be a reflexive relation if for each A, that is for each element A belonging to this set A related to A holds, right? So the relation R is said to be reflexive if for each A belonging to the set A is related to A, right? So it means each element is related to itself. Now, this relation R is said to be symmetric if we have A related to B. It means if we have two elements A and B belonging to the set A, and if A related to B implies B related to A, right? Then this relation R is said to be symmetric. So for the relation R to be symmetric, if A related to B, then B related to A, it must hold, right? And this relation R is said to be transitive if we have three elements, say A, B, and C belonging to the set A, and if we have A related to B and B related to C, if we have A related to B and B related to C, and these two implies that A related to C, right? So if A is related to B and B related to C, then this A must be related to this element C, right? So when this happens, then the relation R is said to be transitive, right? And in a set A, if all these three relations, that is reflexive, symmetric, and transitive relation holds, then we can say that this relation R is an equivalence relation, right? So in the given problem, we have to show that this relation R, which is defined as mod of A minus B is less than or equal to 1, it is not an equivalence relation, right? So let us start. So let us first take up the reflexive relation, right? So here we are given the set A as Q, right? So we have A is equal to Q, which is the set of rational numbers, right? Now we can see that the relation R is defined as mod of A minus B is less than or equal to 1, right? Okay, now if we have an element say A which belongs to our set Q, then we can easily see that mod of A minus A, right? Mod of A minus A is mod of 0, and mod of 0 is equal to 0, right? And this 0 is obviously less than a 1, right? So we can say that mod of A minus A is less than 1, right? And we can see that from this definition of relation R, that is mod of A minus B is less than or equal to 1. Here we have mod of A minus A is less than 1. So this implies that A is related to A for all A belonging to the set of rational numbers Q, right? So we have obtained A related to A. It means each element of this set Q is related to itself. So we can claim that this relation R is reflexive, right? Now let us consider the symmetric relation. So now to consider a symmetric relation, let us consider two rational numbers, that is A and B, belonging to the set of rational numbers. Right? Now this relation R is defined as mod of A minus B is less than or equal to 1. So it implies that A is related to B, right? Which is our definition of relation R, right? Now if we take negative sign common from A minus B, then we have negative of B minus A here, and we can write less than or equal to 1, and we can easily see that mod of negative B minus A can be written as a mod of minus 1 times B minus A, which is equal to mod of minus 1 times mod of B minus A, and mod of minus 1 is equal to 1. So here we have 1. So this is 1 times mod of B minus A, that is mod of B minus A, right? So mod of A minus B less than or equal to 1 implies that mod of negative of B minus A is less than or equal to 1, and mod of negative of B minus A is equal to mod of B minus A, that is less than or equal to 1, right? So from this expression we can see that B is related to A, right? So we have obtained that when A and B belongs to the set of rational numbers Q, then A is related to B, and we have also obtained mod of B minus A less than or equal to 1. So it implies that B is related to A, right? So we have seen that A related to B implies that B related to A, which suggests that this relation R is symmetric, right? So R is a symmetric relation, right? Now let us consider the transitive relation. So now to consider whether this relation R is transitive or not, what we will do, let us consider three elements 1, 2 and 3 belonging to the set of rational numbers Q, right? Because 1, 2 and 3 are the three rational numbers, right? Now 1 related to 2 implies that mod of 1 minus 2 is less than or equal to 1, right? Which is true, because mod of 1 minus 2 is mod of minus 1, that is equal to 1. So 1 is obviously equal to 1, right? And 2 is related to 3 because mod of 2 minus 3 is less than or equal to 1, and again mod of 2 minus 3 is mod of minus 1, which is 1. So 1 is equal to 1, right? So we have 1 related to 2 and 2 related to 3, right? So now let us see whether 1 is related to 3, right? Because in transitive relation, what we do, if we have three elements A, B, and C belonging to the set A, and if A related to B and B related to C exist, then these two must imply that A should be related to C. So now let us see whether mod of 1 minus 3 is less than or equal to 1, right? So mod of 1 minus 3 is equal to mod of minus 2, which is equal to plus 2, right? And we can see that 2 cannot be less than or equal to 1, right? So this is not possible, right? So here we can write this is not possible. So we can see that when 1 related to 2 and 2 related to 3, then we cannot have 1 related to 3, right? So this suggests that this relation R in the set of rational numbers when mod of A minus B is less than or equal to 1 is not transitive, right? So we can say that this relation R is reflexive and symmetric, but it is not transitive, right? And hence, this relation is not an equivalence relation, because we know that if a relation R is reflexive, symmetric, and transitive, then only the relation R is said to be an equivalence relation. But here, the relation R is reflexive and symmetric, but it is not transitive, as we have proved it not transitive by taking this example. So this relation is not an equivalence relation. Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from relations and functions related to the concept of equivalence relation, right? So here we have a problem in which we are given that R1 be a relation defined on the set of real numbers R, as R1 is defined as all ordered pairs A comma B belonging to R cross R, such that sine square A plus cos square B is equal to 1, and we have to show that this relation R1 is an equivalence relation for all ordered pairs A comma B, which satisfy this relation, that is sine square A plus cos square B is equal to 1. So let us start. So viewers, here what we have to do, we have to show that this relation R1 is reflexive, symmetric, and transitive, right? Because we know that if a relation is reflexive, symmetric, and transitive, then the relation is said to be an equivalence relation, right? So what we will do here, we'll first define and quickly define the definition of reflexive relation, symmetric relation, and transitive relation, and then we'll apply the definitions to this problem. Suppose we are given a set A, right? And if an element A belongs to the set A, and if each element of this set A is related to itself, right? If we have A related to A, then the relation R is said to be reflexive, right? So reflexive means if we have an element A which belongs to this set capital A, and if each member of this set A is related to itself, then the relation R is said to be reflexive, right? And in case of symmetric relation, if we have two elements, say A and B, belonging to the set A, and if we have A related to B, implies that B related to A, then the relation R is said to be symmetric relation, right? And in case of transitive relation, if we have three elements, say A, B, C, belonging to the set of A, then if we have A related to B and B related to C, B related to C, and if A related to B and B related to C exist, then A is related to C, implies that the relation R is a transitive relation, right? And if any relation R satisfies these three properties, that is, the relation R is symmetric, reflexive, symmetric, and transitive, then the relation R is said to be an equivalence relation, right? So let us apply these definitions to this relation R1. So here, this set A is given to be the set of real numbers, right? So we have A is equal to R, and R is the set of real numbers. Now the relation R1 is defined as sine square A plus cos square B is equal to 1 for all ordered pairs A comma B belonging to uh, R cross R, right? So A comma B belongs to this set R cross R, where this ordered pair has two numbers A and B, and these two numbers A and B belonging to the set of real numbers R, right? And this ordered pair, it satisfies this relation, that is sine square A plus cos square B is equal to 1. So let us first see whether this relation R1 is reflexive or not, right? So let us consider the ordered pair, that is A comma A belonging to R cross R, right? So here A, this element A belongs to the set of real numbers, right? So A comma A belongs to the set R cross R, and if we take this relation R1, here we have sine square A plus cos square B is equal to 1 for these two elements or members A and B, and here we have A comma A. It means B should be replaced by A, right? So if we take A comma A in this relation, then we have sine square A plus cos square A, right? And from trigonometry, we know that sine square A plus cos square A is always equal to 1 for all A that is belonging to the set of real numbers, right? So what we have obtained here, we have sine square A plus cos square A is equal to 1 for all A comma A belonging to the set of R cross R, right? So it means this relation R1 is reflexive, right? So we can claim that R1 is reflexive, so it means A is related to A, right? So each element A is related to itself, right? Because sine square A plus cos square A is equal to 1 for all A belonging to the set of real numbers, and this is the well-known trigonometric identity. Now let us see whether this relation R1 is symmetric or not, right? So let us again consider the ordered pair A comma B belonging to R cross R, right? Now see, when we have A comma B, that is A is related to B, then we have this relation that is sine square A plus cos square B is equal to 1, right? And from trigonometry, we know that sine square theta is equal to 1 minus cos square theta, right? So let us replace sine square A by 1 minus cos square A, right? And here we have cos square B. So we know that cos square theta is 1 minus sine square theta. So let us replace cos square B by 1 minus sine square B, right? And this is equal to 1. So here we have 1 plus 1, 2, and we can take negative sign common. So we have sine square B plus cos square A is equal to 1. So this equation can also be written as 2 minus 1, taking 1 to this side, and this entire term to the right hand side. We have plus sine square B plus cos square A, right? So now we have sine square B plus cos square A is equal to 2 minus 1, that is equal to 1, right? And now let us observe this relation. This is sine square B plus cos square A is equal to 1. So this implies that B is related to A, right? See, when A is related to B, we have sine square A, then cos square B is equal to 1. And here we have sine square B plus cos square A is equal to 1, right? So comparing this relation and this relation, we can easily conclude that B is related to A, right? So what we have obtained, when A is related to B, then B is related to A, which suggests that this relation R1 is symmetric, right? So now let us consider the transitive relation. So for transitive relation, let us consider three real numbers A, B, C belonging to the set of real numbers, right? So now when we take this ordered pair A comma B, it means we have to take A related to B, right? When A related to B, then we have this relation, that is sine square A plus cos square B is equal to 1, right? So we can take this as equation number 1. Now let us take the ordered pair B comma C. It means B is related to C, right? So when B is related to C, then we have from this relation we have sine square A. A is now B, so we have B here. Then we have cos square B. B is now C, right? So we have here cos square C is equal to 1. So this is equation number 2, right? So what we have done here, we have taken three elements A, B, C belonging to the set of real numbers. When we have the ordered pair A comma B, it means A is related to B. So sine square A plus cos square B is equal to 1. When we take the ordered pair B comma C, it means B is related to C. Then we have sine square B plus cos square C is equal to 1. So now we have two equations. Now let us add these two equations. So what we have, sine square A plus cos square B. Then we have sine square B, and then we have cos square C, and here we have 1 plus 1, that is equal to 2, right? Now let us combine these two terms, that is cos square B plus sine square B, right? So we have sine square A plus cos square C, right? And here we have cos square b plus sine square b. We have sine square b plus cos square b, that is equal to 2. And from trigonometry we know that sine square theta plus cos square theta is equal to 1. So sine square b plus cos square b is equal to 1, right? So we have sine square a plus cos square c plus 1 is equal to 2. So now we have sine square a plus cos square c is equal to 2 minus 1, that is equal to 1, right? So we have sine square a plus cos square c is equal to 1. So now we have obtained this important relation, right? Sine square a plus cos square c is equal to 1. And if we compare this relation with this one, then we can see that a is related to c, right? A is related to c. So what we have obtained, we have a related to b and B related to C, right? B related to C, and these two together implies that A is related to C, right? A is related to C, and this suggests that this relation R1 is transitive, right? Because it obeys the definition of transitive relation, which says that if A is related to B and B is related to C, then A is related to C, right? And this is exactly what we have obtained. So, viewers, from this discussion, we have seen that this relation R1 is reflexive, symmetric, and transitive, and hence we can conclude that this relation R1 is an equivalence relation, right? Because this relation R1, it satisfies these three properties, that is, it is reflexive, symmetric, and transitive.